so here we go. Triangle similarity. So one more time, two triangles are similar if the only difference is their size. You might have to turn or flip them, but if you look at these triangles, they are all similar. So they're not all facing the exact same direction, but if you look at the angles, there's a 1, a 2, and a 3 mark, and they're just kind of turned different directions, but they are all similar. The two main things that have to happen for triangles to be similar is corresponding angles have to be congruent and corresponding sides are proportional. So again, if you look at these angles, we have a 1 mark here, 1 mark here, double mark, and then the triple mark. So angles are congruent. That definitely happens. And then the second part is that the sides have to be proportional. Remember, you get that by creating fractions or ratios out of the corresponding sides. So, for example, 4 and 2 are corresponding. 4 over 2 is 2. 6 is corresponding to 3. 6 over 3 is 2. And then lastly, 8 and 4 correspond. 8 over 4 is 2. And so right here, when we get 2, 2, 2, that proves that they're proportional. When all the corresponding sides have the same ratio, it's also called a scale factor. So I just went through and did it, but every time I did the ratio, I always got 2, and so this is considered our scale factor. All that means is that this triangle is 2 times bigger than this one. So there are 2 options every time you have a scale factor. So a lot of people told me scale factor is 5. So if you say scale factor is 5, you were taking the blue triangle and doing 25 divided by 5 and getting 5. What this means is the blue triangle is 5 times bigger than the green. Some of you did it the opposite direction, still completely correct. You said, okay, 5 over 25 is 1/5, and all that means is the green triangle is 1/5 the blue one. Either then it says, when we aren't told that the angle's congruent, it creates a lot more work for you. So if you want to prove that these triangles are similar, you have to do so much work. So you have to first prove that all the angles match up. So right here, if I only have 2 of them, I have to find the third one. So I have to add those 2 together. I get 140. I have to subtract that from 180. And then I find this third angle. And so if you start looking at the angles, these 2 match, these 2 match. If you find the third one over here, you follow the same process. Okay, these 3 match. So, all that work to figure out that all the angles match. Then you also have to prove that the sides are proportional. So then you have to go through and match up your sides. So 6 is the smallest, 1 is the smallest. 6 over 1 is 6. And then you keep going. So 18 is the middle, 3 is the middle. 18 over 3 is 6. And then you have to do the largest side. So 24, 4. It's still 6. And so then finally, after all of that, you can say, oh yeah, these are similar. If they're similar, it might say, what's the scale factor? And just remember, the scale factor is whatever these ratios end up being. So we would say, okay, scale factor is 6. I gave you 3 shortcuts so that you don't have to do all of that work. So here's your shortcuts. You can do side, side, side similarity. And all you have to do is show that all 3 sides are proportional. And so I already did this one for you. It's all set up. I made my fractions, and then they all ended up being 1/3. So I can say, oh yeah, these are side, 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 similar. The second one is side, angle, side. And so you have two sides that are proportional. So I have 1/3, 1/3. And then right here, I have an angle that's congruent. So that's side, angle, side. The third way is proving that two angles are congruent. So those are shown for you. And that's angle, angle, similarity. Okay, perfect. So most of you are getting the correct answer for this one. If you look, there's only angles labeled. So we would want to look for angle, angle. There's no sides labeled at all. Okay, what about purple? Which shortcut would you be seeing here? Awesome. So this one, you have a side, an angle, a side. It would be side, angle, side. Okay, and then probably the toughest one. What shortcut are you seeing here? I'm only seeing two sets of sides that are labeled for each triangle. So big triangle, small triangle, small triangle. There are no sides labeled out here. We don't know what those are. So can't be side, side, side. I don't have any angles. Can't be angle, angle. So it's got to be side, angle, side. The reason is both triangles share this angle, so you can mark it. So then in this final example, this is bringing it all together. So for the red triangles, what shortcut would I be looking at? Would it be side, 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 angle, side, or angle, angle? Three of you told me side, side, side. Okay, so what that means is I'm checking the proportions. So I line them up and I see if they end up being the same. So smallest is 2, smallest is 16, 2 over 16 is 1/8. The middle is 4, middle is 30, 4 over 30, 2/15. If they don't match, they're not similar. So stop what you're doing, write not similar. There is no similarity statement. There is no scale factor. Okay, going over here to purple. What shortcut should I check? Okay, so we're going to check side, angle, side. The angle part right here, already good to go. You just have to check the two sides. So smaller side is 4 and smaller side is 16. 4 over 16 is 1/4. Larger side's 8 and 32. 8 over 32 is also 1/4. So these are similar because side, angle, side. You could write a similarity statement if it asks you to. Scale factor is 1/4. What about green? What should I be checking for green? All right, we're checking for angle, angle. So right now, I see that the 66s match up. I just need to figure out, is this going to be 14? So if I take 100 plus 66, I get 166. 180 minus 166 is 14. So if I label this, I have two angles that match. So yes, they're similar by angle, angle. I can't do a scale factor over here because I don't have any sides. So scale factor, not sure. And then these ones over here, I feel like are the ones that you guys don't like the most. If it freaks you out that the triangles are stacked, draw yourself a picture of two triangles that aren't stacked up. So what I mean is, here's the first triangle. It's this little one that I just shaded in red. If I redrew that over here, it looks like this. The larger triangle is this one in blue. If you want to redraw it, it would look like this. The top side's labeled 27. you don't have this part labeled, but you can definitely figure out because this piece is 5, this piece is 10, whole thing is 15. If you look at the picture, let me erase my scribbles. Can you see how the two triangles both have this angle right here? They share it. It's the same in both. So you can mark that angle. And now hopefully you can see that you're testing for side angle side and you're just comparing again. So if I put 5 over 15, I get 1/3. 9 over 27, 1/3. They're similar because side angle side, and the scale factor is 1/3.